Today we're going to be learning about effective factors. Our objective is that we'll be able to calculate the effective factor of multiple increases or decreases, and we will be able to use effective factors to calculate future values. So, your friend arrives at your house. Today's newspaper contained a 20% off coupon at Old Navy. The $100 jacket she's been eyeing all season was already reduced by 40%. She clipped the coupon, drove to the store, selected her jacket, and walked up to the register. The cashier brought up the price at $48. Your friend insisted that the price should have been only $40. The store manager arrived, re-entered the transaction, and again the register displayed $48. Your friend left without purchasing the jacket and drove to your house to tell you her story. So, first you determine the ticketed price that reflects the 40% reduction. At what price was Old Navy selling the jacket? So, since it's a reduction, 100 minus 40% would be 60%, which is a decay factor of 0.60. $100 times 0.60 means the jacket's down to $60. That's what the 20% coupon is going to come off of. So 20% discount, 100 minus 20 is 80%. So our decay factor would be 0.80. 60 times 0.80 gives us $48. So your friend was thinking you take the 20% and the 40%, which means you're getting 60% off. That's how she got $40. However, the coupon applies to the discounted price, not the original price. So what if we did in the opposite order? What if we took the $100 jacket, applied the 20% coupon, which we said would be an 0.80 decay factor. So that brings the jacket down to $80. Take the $80 and use the 40% discount, which we said is a decay factor of 0.60. The jacket's still $48. So which sequence of discounts gives the better sale price? They are the same. So let's look at another situation. A stunning $2,000 gold and diamond necklace you saw was far too expensive to even consider. However, over several weeks you tracked the following successive discounts: 20% off list, 30% off market, and an additional 40% off every item. Determine the selling price after each of the discounts is taken. We can calculate the final sale price from the original by using a single chain of multiplication. So we don't have to do it piece by piece as long as we know the decay factor for each. So the decay factor for 20% off would be 0.80. For 30% off, it would be 0.70. And for 40% off, it would be 0.60. So we take the $2,000 that the necklace costs and multiply it by all three decay factors. And now the necklace is down to $672. So what we're actually using are effective growth or decay factors. And what these are the product of all growth or decay factors in whatever situation you're in. Since they are a product, this means they're being multiplied. The effective factor stays the same regardless of the order in which the changes are applied, because it doesn't matter what order we multiply things in. So let's calculate the effective decay factor for the necklace. So our decay factors were 0.8, 0.7, and 0.6. Which gives us 0.336. So if we change that to a percent, that's 33.6%. That's the percentage we're paying of the necklace. So we only paid for 33.6% of the necklace. So it was discounted by 66.4%. What about for the Old Navy jacket? So if we go back, those decay factors were 0.8 and 0.6. Which gives us an effective factor of 0.48, which would be, we paid for 48% of the jacket, which means it was discounted 52%. So what about cumulative increases? So those previous two problems were cumulative decreases. So your fast food franchise is growing faster than you had imagined. Last year you had 100 employees statewide. This year you opened several additional locations and increased the number of workers by 30%. With demand so high, next year you will open new stores nationwide and plan to increase your employee roll by an additional 50%. So the growth factor corresponding to a 30% increase would be 1.30, because we do 100 plus the increase. The growth factor for a 50% increase would be 1.50. So the effective growth factor, we would multiply our two growth factors together. So 1.95. So that would be 195%. So the effective growth would be a 95% increase. So if we had 100 people last year, we're going to have an effective factor of 1.95. We'd have 195 employees next year. So what goes up often comes down. So what if we have increases and decreases? So you purchased $1,000 of a recommended stock last year and watched gleefully as it rose quickly by 30%. Unfortunately, the economy turned downward and your stock recently fell 30% from last year's high. Have you made or lost money on your investment? So the growth factor corresponding to a 30% increase would be 1.30. The decay factor corresponding to a 30% decrease would be 0.70. Remember, we take away from 100%. So the effective factor would be 1.30 times 0.70. Which gives us a factor of 0.91. So is this a growth or a decay? It's a decay because it's less than 1, so it's less than 100%. What would be the effective percentage change? So 0.91 would be 91%. Subtract that from 100, we'd have a 9% loss. So what's the current value of our stock? We started with $1,000. Our decay factor, or effective decay factor, is 0.91. So now our stock is down to $910. what would happen if the 30% decrease happened first and then was followed by the 30% increase. We'll remember back to when we first defined effective decay factors. The effective factor stays the same regardless of the order the changes are applied. So it would have the same result. That's all for today. I'll see you in class.